In this video, we're going to look at first order linear differential equations and how we can make them what is called exact. Okay, so first of all, a first order linear differential equation is of the form dy by dx plus py equals q. That's a first order differential equation because it's the highest dy by dx, the highest differential is 1, so just dy by dx. There's no d2y by dx squared, so it's first order. But it's also in this form, so this is a very particular type of example here. So it's in this form here, dy by dx plus py plus q. Equation of this form is said to be exact when one side is the exact derivative of a product and the other side can be integrated with respect to x. So both those things need to happen. So this side here, you could write that maybe as the derivative of something of a uv by dx, and also this side you could integrate with respect to x. Okay, so that's really where we want to get to. So it's not always, equations aren't always exact, but we can, if they're in this form, dy by dx plus py equals q, we can make them exact, and we'll see how we can do that. Okay, so pardon me. We're going to look at this example. It says, consider this differential equation, dy by dx plus y over x is equal to x squared. Now, if you multiply through, that is not exact at the moment. So why it's not exact is because this side here is not the derivative of one single product. But if you multiplied it through by x, what you would get is x times dy by dx plus y is equal to x cubed. Now, this thing can then be written as the derivative of x, y with respect to x. Now, I'm just going to look at why that is. This is a bit people find it tricky or why it is. And you need to nearly just build confidence that it does work, this process, whenever we see it. So let's just look at this thing. If I was differentiating x, y with respect to x, I'm going to show that that is equivalent to this line up here, the left-hand side of that line up here. So if we do this, just write down the first. This is your differentiating uv. You get u times the derivative of v plus v times the derivative of u. So if I just write down the first one, I get x. And if you differentiate y with respect to x, you get dy by dx. And then if I write down the second one, which is y, and I differentiate the first one, so differentiate x, you get 1. So that's what you have. So it's x dy by dx plus y. So you can see that then this is now true. So this left-hand side could just be written as this left-hand side. Okay, and what you go on to do then, after that, in your next line, you just integrate both sides. So if you integrate dxy by dx, if you integrate that, you'll just get xy. And if you integrate the right-hand side, it's just the integral of x cubed. And then that becomes xy is equal to x to the 4 over 4 plus c. And then you could go on and make y the subject if you really wanted to here from this. Okay, so in this case, the integrating factor is x, and that was because, remember, we had to multiply this by x to make it exact. Now, the problem is, how on earth do we just randomly go through all different functions and think, what could it be? Thankfully, there's a method for doing this. Okay, so the method for doing this says the integrating factor is given by f of x, where f of x is equal to e to the integral of p dx. Now let's look back at what p is. So if you have it in this form, an equation in this form, dy by dx plus py is equal to q. P is whatever is multiplying the y. So down here, in this one, sorry, I'm on my highlighter, should be on my pen. In this one here, p is what's multiplying your y? Well, it's being divided by x. That's the same as multiplying by 1 over x. So if we look here, you can see in the last example, p was equal to 1 over x. And then if you do this, the integral of e to the 1 over x, that becomes the integrate 1 over x with respect to x, you get ln of x. And e to the power of ln of x just gives you x. And remember, that's what we had to multiply through by to make it exact. Okay, so the big takeaway from this then, and then we'll look at an example or two maybe in this. It says, so if the linear equation dy by dx plus py equals q can be solved by multiplying, I have an extra g in my integrating, by the integrating factor, e to the px, provided e to the px can be found, and also the right hand side can still be integrated with respect to x. So it says here in this one, it says in this example, find the general solution. Sorry, let me bear with me, I'll delete all this out so we can actually go through it with you. Okay, right, so we're going to go look at this example. We spoiler there for you. All right, it says, find the general solution of the differential equation cos of x dy by dx plus y sine of x is equal to sine of x cos cubed of x. Okay, first of all, it's not in this form. It's not in this form, dy by dx plus py is equal to x. So the first thing you've got to do is divide through to make it that in that form. So let's just write down the equation. Write down the equation again. So the equation was cos of x dy by dx plus y sine of x is equal to sine of x cos cubed of x. So first divide through by cos to get it in this form. So then it now becomes dy by dx plus y, and then sine x, I'm just going to write that as sine x over cos x. I'll write that bit first. Remember, you want the p to be in front, really. And then this becomes sine of x cos squared of x. Right, first of all, let's have a look. Is this right-hand side, can you integrate it? Is it integratable? It is indeed, absolutely. You can integrate sine x cos squared. And we should be able to go from here then. So we'll call this equation 1, and we're going to come back to equation 1. We'll be changing how it looks. IF then is our integrating factor. It's going to be equal to e to the integral of sine x over cos x dx. And it's much easier if you leave it in this form. So that's going to be e to the minus ln of cos x. And then we'll just change that. That's a wee bit awkward. That's e to the ln of cos x to the minus 1. Bringing that minus up. And then that is the same as e to the ln of sec x. And then if you do e to the ln of anything, the e and the ln cancel each other out. So it just gives you sec x. Okay, so what we have now got to do is multiply through by the sec x. So your equation 1 up top there gets multiplied through by sec x. So it becomes sec x dy by dx. And then if you multiply that by sec x, you're just going to get tan x, sine over cos is tan x, and then sec x, and then y. And then if you multiply the cos squared by sec x, it just becomes cos, so it becomes sine x cos x. Now let's just check this right hand side. You can still integrate it. That's going to be fine to integrate. And then the right hand side. So the right hand side you can integrate it, and the left hand side is the derivative of a product. Now this is the next bit that people have trouble with, is thinking, well, what is this as a derivative of a product? So think about it this way. You've got your dy by dx. You've got a dy by dx term. So that clearly is when something has been differentiated. That means this bit hasn't been differentiated. Okay, and then v then is when the y hasn't been differentiated, and tan x sec x is whenever the u has been differentiated. So then that means you can pick out what the u is. It was just sec x, and you can pick out what the v is. It was just y. So then that means you can rewrite this whole thing as a derivative of uv, and our u is sec x. Our u is sec x. And our v is just y. All right, and it's probably easier to write that. It's probably nicer to write that as y times sec x. All right, so that's what that whole thing is. It's a derivative of y sec x, and the right-hand side, I'm just going to write it still as sine x cos x. I don't want to do too much in each step. Okay, now we'll sort out the right-hand side now. So the derivative of our y sec x on the left, it's still the same. Right-hand side, remember that sine of 2x is equal to 2 sine x cos x. So that means what we have is only one of those, so sine x cos x, which is a half sine of 2x. So that's how we can write that over here as a half times sine of 2x. From there, you can integrate, and you can integrate this right-hand side really easily now. The left-hand side integrates really easily to give you y sec x. The right-hand side then is going to be minus a quarter. So just remember, if you integrate sine mx with respect to x, what you get is minus 1 over m cos mx. So that plus c, your angle bit stays the same. So here, that would be integrate sine 2x, you'll get minus a half cos of 2x. You've also got a half in front, so minus a half times a half gives you minus a quarter cos of 2x, and then plus your constant of integration c. And I think that's as far as we can go. Did it say find a general solution? So this, folks, is a general solution because you've got your constant of integration. So that's as far as we can go. Okay, one more of this type. I'll probably have to go through and delete this all again. I do indeed, apologies. Right. We'll do better on the next video. I'll have it all pre-deleted. Okay, right. Next one, and our last one for this video. It says, find y in terms of x, given that dy by dx is equal to, dy by x minus 2 over xy is equal to x squared ln x. Right, first of all, it's in this form, dy by dx plus py is equal to q. And the right-hand side is integratable, not particularly easily, and the left-hand side is in the form that we want. So we then can say that our integrating factor is equal to e to the integral. I'll move down a wee bit here. My integrating factor is equal to e to the integral, and it's of minus 2 over x dx. So if you integrate that, you're going to get e to the minus 2 ln of x, which is e to the ln of x to the minus 2, which is just the e and the ln cancel, which just gives you the x to the minus 2. So basically, to make this an exact thing, we have to multiply through by e to the x. So it becomes, multiply through to x to the minus 2. So x to the minus 2 times dy by dx, and then x to the minus 2 times this is going to be, you have minus 2 times 1 over x times x to minus 2. That will have shown, omitted a wee bit of working out, but that would be minus 2x to minus 3y. And then over here is just going to be ln of x. So definitely that looks a wee bit easier. Okay, right. Now this is a bit people don't like. You really got to just trust that this works. So here, my dy by dx, that's clearly like my v differentiated. So this bit then must be my u. And then here, my y is clearly not differentiated. So this must be my u dash. So here, let's just check that and see. If you differentiate x to minus 2 with respect to x, what do you get? So we're hoping we get our u dash here, which is minus 2x to minus 3. So differentiate x to minus 2, multiply by power, you'll have minus 2, reduce your power by minus 1. So happy days, we've got what we wanted. I wouldn't be writing any of these bits in red down when I'm doing this, to be honest. Experience has told me it works, so I trust this method. I would just jump from the bit in blue to this next bit in blue. So x to the minus, y times x to minus 2, just a wee bit nicer to write it that way, dx is equal to ln of x. So if you integrate the left-hand side, you're just going to get y, x to minus 2. And integrate the right-hand side, you're going to get the integral of ln x dx. Okay, folks, we can't get away from this. This is a very common integral that they love to ask you. This is a special integration by parts. So we're going to have a wee look at this. Okay, we'll come back to this. Call this equation 1. We'll come back to it. We're going to look at integrating ln of x dx. So you would rewrite that as the same as, the integral of 1 times ln of x dx. And this is a special one which you must learn. Normally you would let your u be equal to the simpler thing, but in this case your u is equal to ln of x, and your dv by dx is equal to 1. So your du by dx, differentiate that, you get 1 over x, and integrate your dv by dx, integrate 1, you will just get x. So that means, we'll just do that here, that means the integral of 1 times ln of x, remember this is integration by parts, so my result is uv, which in this case is x ln x, then minus, and then it's the v du. So if you do minus v du, so that's going to be x times 1 over x dx. So what that works out to be is x ln x minus the integral of 1, which is just going to be x ln x minus x, and then plus your c. So equation 1 becomes, I'll change how I write my left hand side. I'm going to write it as y over x squared, and my right hand side, I now know the integral of ln of x is x ln x minus x, and then plus c. And then we'll just go ahead and look at the constants. So it tells you in this question, y equals 2 when x equals 1. So let's just put that in. When x equals 1, y equals 2. That's going to be 2 over 1 is equal to 1 times ln of 1 minus 1 plus c. Ln of 1 is 0, so that's just 2 is equal to 0 minus 1 plus c. Wee bit of working out, 3 equals your c. And then you'll just say, therefore, you've got y over x squared is equal to x ln of x minus x plus 3. And therefore your last line, I would multiply through by my x to get y is equal to x cubed ln x minus x cubed plus 3 x squared. And that is it done.